This is the counterpart of ionization energy. It is called electron affinity, and it is abbreviated as EA. So it is an energy, and it's associated with the process of adding an electron to a gaseous atom. And yes, this should be a superscript. That is my typo. Please notice that it has a negative value. This negative value indicates a more stable ion. And we'll talk about that in a moment when we talk about the electron configuration. That is the first electron affinity. The second electron affinity, it always requires energy. Why is that? You're trying to force an electron onto a negatively charged ion. So we talk a lot about the oxygen ion. The electron affinity here is a negative for EA1, but when we look at EA2, we notice it has a positive value. So in a way, why does this happen? Well, oxygen has, if it goes to a -2 ion, it gets a full shell, and that will be the driving force. Again, insight. There's the facts, and then there's insight. Please, the trend is not well established. I will have students come up to me and say, but if I look at this versus this, it says this, it says this. We are called Gen Chem. Please just accept the fact that in this course, we will say the trend is not well established. What will you be expected to do? Well, just like with ionization energy, you're going to be expected to write some equations. This homework problem says, write the second electron affinity of chlorine. So what I'm going to do is I'm going to write the first one to start with. I will say Cl as a gas plus an electron makes Cl minus as a gas. And I know it would have a negative value because it's an exothermic process. I also know that if I try to write the second electron affinity to make a Cl2 minus gas, that would be a positive. That would be an endo. Because what have I made here? I have made a noble gas. If I'm trying to stick an electron onto a noble gas, it is not going to happen. So would you predict a positive or a negative? I would predict a positive. Is it possible to directly measure? I'll be honest, I don't even know how to measure the first one. I shouldn't have said that, I'm the teacher. But no, I don't think it is going to be possible, nor should you worry about it in a Gen Chem course. So what else do we have here? Well, they want to talk to you in your textbook in this chapter about an ion-electron configuration. So first we have our anion, and what they say, you always add it to the orbital with the highest N. Think about what a P5 looks like. We have this electron configuration. If I add one electron in, I will make a full shell. That's what drives all of these things. Think about how you had to memorize F minus back in chapter 2. And you said, why do I have to do this? What does this really mean? Well, now that we're into chapter 7, we can show you with the electron configuration and you have an understanding of electron affinity why these things take place. I just included the cation here because that's what your textbook did. But this is a skill that we hope that you can develop by learning this material. Finally, I want to work this one with you because I've had questions on this during office hours. It has many parts. First, it says, what is the name of this product? Well, think back to chapter 2. This is dichlorine, and it would be heptaoxide. Okay, that would be its name. Write a balanced equation. This is where I get a lot of pushback from people. It says that chlorine reacts with oxygen in order to form Cl2O7. Okay, so that would be its equation, and then what you'd have to do is balance it. If you had a 7 halves here, this would turn into 2Cl2 gas plus 7O2 gas goes to form 2Cl2O7. And I'm trying to say, oh, here it says there is the liquid. So I skipped that in the first one. Now again, we are more than halfway through this course. Everyone should know that chlorine and oxygen are diatomics. Everybody should know they're gases. Did I know Cl2O7 was a liquid? Absolutely not. Then it says, would you expect that material to be more active towards an acid or a base? At this point, you do not know, because that is coming up in a following section, but I am just going to write it here. Cl2O7 as a liquid, this is an acidic material. We're going to teach that in a section coming up. Because it is an acidic material, I'm going to write down here acid. This is going to react with a base, and what it's going to do is it's undergoing a neutralization reaction, plus it will make one of your least favorite ions, the perchlorate ion. I don't think anyone watching this would know this is true. You would have to take a look at the homework problem first, but now that you've seen it, you know that this is a non-metal oxide, and I'll be teaching you that non-metal oxides are always act as acids in solution. My last one was the favorite. The last one says, the oxygen in dichlorine heptaoxide is considered to have a -2 oxidation state. What is the oxidation state of chlorine? Well, back in chapter 4, we talked about redox. And here they even tell you this is a -2. -2 times 7 is -14. How can I get a zero charge? I need a +14. But there's 2 chlorine atoms, so each of these will be a +7. To be honest, this is why I like chemistry. I'm not thrilled with reading the textbook. I really like to work problems, but really, the thrill I had was working in industry where we had products that we were making, where we didn't know how we were going to do it. We would have a starting point, we would fail a lot, but essentially in the long run, we could produce something that someone needed. These are kind of like the baby steps. You've got to know these facts in order to step into a professional situation, no matter what it is. I think of people that maybe are going to go into physical therapy. You're going to learn all about what the body, everything, the physiology of the body, but you also have to know a little bit about the chemistry, like what is going on as these things are happening. So again, this is more or less an academic exercise. It's a problem-solving exercise. So again, it is a challenge for you. I'm going to do this problem also because this is the one where people will show up at office hours. And I'm kind of sad I'm doing it here because maybe then no one will show up. But this one talks about the chemical process called electron transfer. And if you look at the equation, you see that there's a positive and a negative. And they say here a simple reaction is follows. In terms of ionization energy and electron affinity, what is really going on here? So what we want to say is, if I have an element A in the gas phase, I know an it shouldn't have a G, an ionization energy would be looking like this, where we would give off an electron. That would be the ionization energy of A. And that would be the first product we see here. What would we do with the A in the gas phase in order to produce that anion? Well, it would be A minus in the gas phase, and that would be the electron affinity. What happens if I add these two things together? Well, I would have A gas plus A gas going to form A plus gas and A minus gas. Both of these electrons drop out. So this is a hypothetical problem. What's the energy change for the reaction? For an element such as chlorine, is this process exo or endothermic? For sodium, is it endo or exothermic? I will leave that to you because students didn't struggle with that. What they struggled at was this. So imagine you're going to run this using sodium. Look up the values for Na plus and Na minus. They're in that chart. You're going to run this for chlorine. Look up the values for chlorine plus and chlorine minus and decide, is it going to be overall exo or if it's going to be overall endo? And that's what we talk about with insight, where you're taking it to the next step. Now, I'm going to say your midterm exam is not going to be full of questions like this, but there may be a single question. That is how I wrote my exams. Each chapter would have 4 questions anyone could answer by breathing. I always wrote it that way. 3 questions, just a tad harder. 1 more where you crank it up a notch. And then I put something like this on here so I could see the broad spectrum, and so could you, because you are entering a very different world than I did. My world was a pigeonhole of a chemist. In yours, everything is integrated. So please try your best on this, and let's see how we do.